Good morning, dear students, and welcome to Vista's learning and online educational platform. My name is Denzil, your physics tutor for class 11. Let's get started with today's session. Today, we discuss concepts that are related to relative velocity in a two-dimensional motion. This is a session 4 of the chapter Motion in a Plane. So earlier in the previous session, we discussed concepts that were related to acceleration, also how to make note of equation of motion for an object moving in a plane. And we worked on a problem based on it, but this time we will discuss concepts that are related to relative velocity. We discussed the same concept for a motion in a straight line, where we determine the relative velocity of one object with respect to the other. The same discussion will take place, but except this time will be in two dimensions. So before we enter into the session, the last class I left you all with this problem as a homework. And I hope that you've actually done this, solved the problem. But for those of you out there who find it difficult to solve this problem, I will proceed solving it for you and we will have a look at the answer. For those of you who have already solved this problem, just make note of the steps, okay? Just check the steps and then also check the answer. So let's get started. First, let's read the question. It says, a particle starts from the origin at t equals to 0 seconds with a velocity of 10 j cap meter per second and moves in an xy plane with a constant acceleration of 8 I cap and 2 j cap meter per second square. At what time is the x-coordinate of a particle 16 meter? What is the y-coordinate of the particle at that time? What is the speed of the particle at that time? So, three things to find out. One is to find out the time when the x-coordinate of a particle is 16 meter. Second, for the same time, what will be the y-coordinate of the particle? And third, we have to determine the speed of the particle at that same time. So first, we will proceed in determining the time. But before we do that, we have to make note of parameters that are given to us. What are the things that are given? Let's make note. Given speed of the particle is given, velocity of the particle is given at any given instant of time, which is 10 j cap. Okay. Then it moves in an xy plane with a constant acceleration. Acceleration of the particle is given at any given instant of time, which is 8 I cap plus 2 j cap. You could mention as any given instant of time t, or you could just ignore it. You could also ignore this. That is fine. All right. So you could just write v is equals to 10 j cap and a is equals to 8 I cap plus 2 j cap. Next, what else is given? The time. We have to determine the time when the particle has reached 16 meters. This x is a function of time t, which reaches a position 16 meters. So now that we have made note of the parameter, let's go ahead and find what will be the displacement of a particle for this velocity and for this acceleration. How do we find the displacement of a particle? Well, we use a formula that is, do I write it there? Do I write it here? Do I write it there or here? Right there or here? I'll write it here. R equals to Vt plus half at square. R equals to initial velocity of the particle is given. How much? 10 j cap. 10 j cap times t plus half. Acceleration of the particle is given 8 I cap plus 2 j cap. 8 I cap plus 2 j cap t square. So we put them, we multiplied the t half. So you divide and then you multiply by t square. Since we're dividing, I will not write this 1 by 2 anymore. So I get 4 t square I cap plus t square j cap. Now I'll bring all the I cap and j cap terms together. So I have only one I cap term. So 4 t square I cap plus 10 t plus t square j cap. All right. So we have a basis vector for x coordinate and a basis vector for the y coordinate. So this basis vector this term represents the x coordinate of a particle. This term represents the y coordinate of a particle. Because we have learned that r can be represented as x I cap plus y j cap. Therefore, I hope that will be visible. Therefore, x of t at any given instant is 4t square. Do we know the value of x of t? Certainly, why not? See, 16 meters. So this is equals to 16. And then you get t square is equals to 16 by 4 then you get t square is equals to 4, which t is equals to 2. You get plus or minus 2, but we don't need a minus in this case because time is a scalar quantity. So you do not need a plus or a minus, just the magnitude will be sufficient. So time taken would be 2 seconds. So we've determined one part of the question, that is time. All right. So as you see, at what time is the x coordinate of particle 16 meter? 2 seconds. Congratulations, you just solved one part of the problem out of 3. So which is the next part? What is the y coordinate of particle at that time? So you already have the time. You also have the y coordinate of a particle. Can you identify where it is located? All right, let me highlight it for you. It is located here. This is the y coordinate of a particle. So that means y of t, which is equals to 10t plus t square, represents the y coordinate of a particle. At that time, meaning at 2 seconds. So by substituting the value of t as 2, so you get 10 times 2 plus 2 square. So y of 2, which is equals to 20 plus 4, y of 2, which is equals to 24 seconds. Oh, sorry, meters. The unit, this is a y coordinate, so meters. Congratulations once again. You have found the solution for the second part of the problem. Okay, one part that says time, you have identified the time. The other part is to identify the y coordinate of a particle at the same time, which you have done. Now for the third part, what do you have to find in this third part? What is the speed of the particle at that time? All right. Do we have the displacement of the particle at 2 seconds? Yes, we do. We just have a displacement of a particle, which is mentioned here. Let me highlight it for you once again. This is the displacement of a particle. Okay. Oh, I have a highlighter. I could use a highlighter. Correct. This is the displacement of a particle. All right. Not bad. Hey, I could highlight. Displacement of a particle r vector, which is 4t square plus 10t plus t square j cap. So using this set of information, we have to get velocity. Velocity is defined as the rate of change of displacement. So v is equals to dr by dt. V is equals to dr by dt. Do we know what are the values for v, the terms that are involved? Yes. Since I've highlighted that, use that, differentiate it with respect to t, and you get the solution v. So 4t square I cap plus, in the bracket, 10t plus t square. 10t plus t square j cap. Okay, since I don't have sufficient space, I hope that is understood, which is 10t plus t square, but nevertheless I will still make it more legible. So this v equals to d by dt of 4t square I cap plus 10t plus t square j cap. Good. So far so good, no problem here. Now we need to differentiate it with respect to time. So v is equals to, so you get 8t I cap. So I'm helping you with the differentiation. So once you multiply that 4t square, you get 8t I cap plus 10 in a bracket plus 2t j cap. Okay, 10 plus 2t j cap. Now, this velocity is a function of time. It's a function of time because you see the terms t involved in the given expression. Now, for a given time, it is already mentioned time, that is 2 seconds. So, what will be the velocity when time t is equals to 2 seconds? Well, let's find out. 8 times 2 plus 10 plus 2 times 2, and you get v, which is equals to 16 I cap plus 14 j cap. Ta-da! We have found what is the velocity in its two respective component, velocity along the x-axis and the velocity along the y-axis. So which means to find the magnitude of velocity, what you do is take the square root of 16 square plus 14 square. So leave this up to you. You can identify by this manner what will be the magnitude of velocity. So I hope I've made that clear as to how to solve this problem. Okay, now moving on to today's actual concept, which is relative velocity. Now in this case of relative velocity, just like the previous session, meaning the last chapter, we discussed how velocity of one object can be identified with respect to another moving object. Let's call these two trains as one train A and the other train B. And when these two trains depart, one train moves faster than the other, no doubts about it. But for a person who is sitting in train A, when he determines the speed of train B, how fast is train B moving with respect to train A? To identify that, we use this concept of relative velocity. Suppose we call velocity of train A as VA and train B as VB. So the velocity of train B with respect to A is given by VB minus VA. So I hope you know this. You remember from the previous chapter where the velocity of train B with respect to A can be identified as VB minus VA. Similarly, if the two trains are moving opposite to each other, and then the train A makes the same observation on train B to identify its velocity, how fast it is moving. So what would be the calculation involved? Suppose let's call the velocity of train A as VA and velocity of train B is VB. But for a reason we know that velocity of train A is in an opposite direction. How do we know if it's in an opposite direction? For one reason, on a number line, we know that objects that are moving towards the right hand side, objects moving along the right hand side are always positive. Number line, so picture number line which you have studied in lower class. Objects moving on right hand side are always positive. Objects moving along the left hand side are negative. Have a look at the two trains. Identify the one which moves in a negative direction and a positive direction. There you go. So train A is moving in a positive. Oh, that's all right. Train B is moving in a negative. That's all right. Okay, let's say train B is moving in a negative direction. Okay, which is in that direction. So velocity of train B with respect to A, which is equals to velocity of train B, but this time it is negative. It is not positive, it is negative. Minus the velocity of train A. You can take the minus factor outside, so you get velocity of train B with respect to A is minus VB plus VA. You may argue or you may question as to why you still have the negative sign. Why is there still a negative sign? Though the two velocities are added, why still the negative sign? That's because the train B is moving in a negative direction. So for a train A, for a passenger in train A, we'll find that the train B is moving in a negative direction. Therefore, it's negative velocity. So these are the things we discussed. Now, same thing we're going to apply for an object moving in 2 dimensions. So here's a quick example or a quick question based on the same concept of relative velocity. So let's read the question. It says, rain is falling vertically with a speed of 35 meters per second. A woman rides a bicycle with a speed of 12 meters per second in east to west direction. What is the direction in which she should hold her umbrella? Interesting one, no? Now for this, we have to understand the compass. Which direction is north, south, east and west? Okay. So quick note about a compass. One second, I'll pick a color. Color, which color do I choose? I hope that is visible. Yes, visible. Upward direction is north. Downward direction is south. Not that hard, isn't it? You would say, duh, upward and downward is north and south. Now, the two other perpendicular arms, there's one way how you can identify, even as practical. All you have to do is try to face the sun, and when you're facing the sun, your left hand always points towards the north side. So if you're facing the sun, the rising sun, all right, if you're facing the rising sun, sun always rises in the east, right? And if you're pointing your hand, your left hand, the direction which is pointing at is at north. So if the sun is rising this way, you see my left hand will be facing the north side. Therefore, this will be east and this would be west. Okay, this is how you can identify the directions north, south, east, west. Then you say you have a better instrument. You say, I'd rather use a compass than just point at things. You could do that, but what if the compass malfunctions? Right? So rain is falling vertically with a speed of 35 meters per second. So what we're going to do here is represent the following case as a vector diagram. These vector diagrams are also called free body diagrams, because here you'll come across in forces in the next following chapter. But just remember, this particular case we represent it using vector diagram. So let's go ahead and represent it using vector diagram. I have rain that is vertically falling downwards with a speed of 35 meters per second. Let's call it VR, where VR is equals to 35 meters per second. All right. Next, a woman rides a bicycle with a speed of 12 meters per second in east to west. East to west. So she's riding a bicycle in this direction. Yeah, I'll put it here. Okay. She's riding a bicycle in this direction. Let's call it VB. So where VB is equals to 12 meters per second. What is the direction in which she should hold her umbrella? What direction she should hold her umbrella? Since the rain is falling vertically downwards and the bicycle which is moving forward, obviously the umbrella is held in a forward direction. So since the umbrella is held in a forward direction, to identify the angle, okay, you could say this angle which is theta that it causes. To identify the angle, we use simple trigonometry ratio. And what trigonometry ratio is that? You have opposite and you have adjacent. Opposite and adjacent gives you tan theta. So tan theta is equals to VB by VR. So which theta is equals to tan inverse of VB. VB is 12, because I've mentioned here, divided by 35. And by identifying this value, you will soon see that angle theta turns out to be approximately 19 degrees. So this should be the angle that a woman should hold her umbrella a little tilted forward. A simple method. So what we did here is represented the given case in a form of a vector. So there's another question, maybe another question the next time, but I hope you've understood these concepts. Do visit us at www.we-learning.in to get more details about the previous classes. I have conducted the bridge course session where I give you an introduction to a differential calculus. Go ahead, take a look at it, because further moving ahead, we will be working more on differential calculus and integral calculus. So I'll see you on the next session. Until then, take care and goodbye.